My name's Yara Mahmoud. I'm a fourth-year software engineering student, and this summer I worked with Dr. Akramul Azim using artificial intelligence, or AI, to enhance how we test software. When developers collaborate on code, they usually store it in something called a repository, and every time they make a change, they leave a small note called a commit message. Think of it like a sticky note that explains what they did and sometimes why they did it. But here's the problem. Commit messages are often written quickly. They tend to be short, inconsistent, and vague, so even though they contain valuable context, they're often overlooked. In large organizations where thousands of developers work on the same code base, the volume of changes is staggering. Imagine a 3-month-long project with 1,000 developers, each making just 3 changes per day. That's 270,000 code changes. Testing all of that? A massive challenge. To keep up, companies use something called test case prioritization, or TCP, to decide which tests to run first for efficiency. And they often use machine learning to help with that decision. But here's the catch. These models mostly rely on numbers, like how long a test takes, or whether it's failed before. They ignore the why behind the change, the deeper context. And that's where my research comes in. We used large language models, or LLMs, like GPT-4 and Llama 2, which can understand and generate human-like language. You might know them from tools like ChatGPT. We fine-tuned these models to rewrite vague commit messages to explain the what and the why of the code change. Then we fed these enhanced messages into our machine learning system as an extra feature to help it decide which tests should run first. We also experimented with different ways of processing the messages and found that a method called TF-IDF, which highlights the frequency and the rarity of the words, gave the best results. The outcome? Our enhanced system was able to detect bugs earlier and prioritize longer, more important tests, leading to faster feedback and saving developers valuable time. It's exciting to see that something as small and often ignored as a better commit message can have such a big impact on software quality. I had the incredible opportunity to present this research at the International Promise Conference, where I shared our findings with a global community of researchers. As a student, this experience has shown me just how powerful the intersection of language and technology can be, and how even small, thoughtful improvements can lead to smarter, faster, and more reliable software. Thank you.